Not all islands are created equal. From simple oceanic landmasses to geographic paradoxes that feel like glitches in reality, these are the 7 increasingly bizarre levels of what qualifies as an island. Level 1, the basic island, pure oceanic form. Let's start with the clean definition. Land, surrounded by ocean, permanently. Hawaii formed over a mantle hotspot as the Pacific Plate moved above it. The visible islands are just the peaks of massive volcanic shields rising more than 30,000 feet from the ocean floor. Measured from its submarine base, Mauna Kea is taller than Mount Everest. Iceland is the basic island with a twist. It sits atop the mid-Atlantic ridge, where the North American and Eurasian plates pull apart by roughly 2 centimeters per year. New land can form fast, like Surtsey, which emerged from the sea in 1963. From the low-lying atolls of the Maldives to the isolated cliffs of Easter Island, Level 1 islands are the reference point. Stable land, meeting open ocean. They simply are. What makes Level 1 islands fascinating is their permanence and independence. The Galapagos Islands, sitting 600 miles off Ecuador's coast, were never connected to any continent. Every species that reached them had to fly, swim, or float across open ocean. This isolation created Darwin's natural laboratory where finches evolved different beak shapes on different islands, and giant tortoises developed unique shell patterns based on which island they inhabited. Easter Island took isolation to the extreme. When Polynesians arrived around 1200 AD, they were 2,300 miles from the nearest inhabited land, creating one of history's most isolated human societies. The island's Moai statues represent what happens when humans are completely cut off from outside contact for centuries. The biological stakes for Level 1 islands are higher than anywhere else on Earth. Because they are born from the seafloor, they begin as sterile volcanic rock. Every bit of life, from the tiniest moss to the largest lizard, is a descendant of a colonist that survived an impossible journey. This creates a bottleneck of evolution where weirdness becomes the norm. Think of the Komodo dragon in Indonesia, or the flightless birds of New Zealand. Without a land bridge to allow traditional predators in, these species grew to massive sizes, or lost the ability to fly entirely. They are evolutionary lifeboats, drifting in a sea that keeps the rest of the world at bay. Level 2, the continental island, cut off by rising seas. Now we move into islands that are islands mostly because sea level says so. During ice ages, much of what's now the Sunda Shelf was exposed, meaning Borneo, Java, Sumatra, and the Malay Peninsula weren't scattered islands at all. They were connected to mainland Asia as one enormous continuous landmass, often called Sundaland. Madagascar split from Africa roughly 88 million years ago. Isolated for so long, its wildlife evolved independently, with over 90% of its species found nowhere else. And if you lower global sea levels by about 100 meters, something that has happened repeatedly during ice ages, islands like Tasmania and Sri Lanka would reconnect to neighboring continents. Continental islands aren't separate by design. They're separated by water level. Great Britain perfectly demonstrates continental island geography. During the last ice age, you could walk from London to Paris across a land bridge called Doggerland. This wasn't just a narrow strip. Doggerland was an inhabited landscape with rivers, forests, and human settlements. As ice melted and seas rose between 10,000 and 6,500 BC, Doggerland flooded gradually, and Britain became an island. Archaeologists have recovered stone tools and mammoth bones from what's now the floor of the North Sea, proving humans lived on land that's currently underwater. The English Channel is only 560 feet deep at its deepest point. It's essentially a flooded river valley on the continental shelf. During the next ice age, Britain will reconnect to Europe, and the cycle will repeat. This category of island is essentially a geological pause button. Because they sit on the continental shelf, they share the same basement rock as the mainland. When you look at the white cliffs of Dover in England and the cliffs of Normandy in France, you aren't looking at two different islands. You're looking at the two sides of a valley that the Atlantic Ocean decided to fill up 10,000 years ago. This is why you find the same fossils, the same coal seams, and the same mountain ranges on both sides of the water. They are the fragments of a broken puzzle, waiting for the next ice age to suck the water back into the glaciers and turn them into a continent once more. Level 3. The river island, born from motion. River islands are temporary by nature, land built from movement. Ile de la Cité in Paris sits in the Seine and marks the historic heart of the city. Its position once helped control river trade and defend settlements. Today, it anchors landmarks like Notre Dame. In India, Majuli is recognized as the world's largest inhabited river island. Formed by the shifting Brahmaputra, it has steadily shrunk due to erosion. Monsoon floods reshape its boundaries year after year, forcing communities to adapt. And then there's Bananal Island in Brazil, nearly 7,400 square miles, created where the Araguaia River splits into two channels before rejoining. So large it contains forests and wetlands of its own. It exists because of water in motion. River islands remind us that some land is only temporarily land. Roosevelt Island in New York's East River demonstrates how river islands function in modern cities. The island is 2 miles long and 800 feet wide, squeezed between Manhattan and Queens. In the 1800s, it housed a prison, insane asylum, and smallpox hospital, facilities that benefited from island isolation. Today, it's a residential neighborhood accessible by bridge, subway, and an aerial tramway. The island was known as Welfare Island when it contained hospitals for the poor and mentally ill, and ruins of the smallpox hospital still stand as a Gothic reminder of when river islands served as quarantine zones. River islands in urban areas create unique neighborhoods, isolated enough to feel separate but connected enough to function as part of the city. What makes Level 3 so volatile is that the ocean surrounding them is flowing in one direction. This creates a conveyor belt of land. A river island is often a massive pile of sediment caught behind a rock or a bend. As the upstream side is eaten away by the current, the downstream side often grows as new silt is deposited. In a very literal sense, some river islands are migrating downstream over hundreds of years. This creates a nightmare for international borders. If a river defines the border between two countries and an island suddenly forms or washes away, the map has to be redrawn in real time. They are islands made of liquid logic, existing only as long as the river allows them to stay. Level 4. The Lake Island, land trapped by fresh water. When we imagine islands, we picture oceans, but some of the most extraordinary islands are landlocked. René-Levasseur Island in Quebec sits inside the Manicouagan Reservoir, a ring-shaped lake formed by a meteor impact around 214 million years ago. When the river was dammed in the 1970s, the crater flooded, leaving the central highland exposed. The result is the Eye of Quebec, a near-perfect circle visible from space. In Lake Superior, Isle Royale covers around 206 square miles and hosts one of the longest-running predator-prey studies in the world. Wolves and moose evolving together in isolation. Within Isle Royale sits Siskiwit Lake, which itself contains islands. In harsh winters, ice bridges can temporarily connect the island to the mainland, blurring its isolation. In Nicaragua, Ometepe rises from a freshwater lake, formed by two volcanoes, Concepcion and Madeiras, that merged over time. The lake is also famous for historical accounts of bull sharks traveling between the Caribbean and the lake via the San Juan River, a rare example of marine predators adapting to freshwater environments. Level 4 creates double isolation, land surrounded by water that is itself surrounded by land. Lake Baikal in Siberia contains 27 islands, and it's the oldest and deepest lake on Earth at 25 million years old and 5,387 feet deep. Olkhon Island is the largest, and it's sacred to indigenous Buryat people who believe it's the home of spirits. The lake is so isolated and ancient that it contains species found nowhere else, including the Baikal seal, the world's only exclusively freshwater seal. Scientists still debate how seals ended up in a lake 2,000 miles from the nearest ocean. The most likely explanation is that seals swam up rivers during an ice age when Baikal connected to the Arctic Ocean, and when the connection disappeared, the seals were trapped and evolved into a distinct freshwater species over thousands of generations. Level 4 islands often feel like parallel universes. Because they are surrounded by fresh water, they support entirely different ecosystems than their oceanic cousins. On islands like Manitoulin in Lake Huron, you have massive forests, deer, and foxes living out their lives in the middle of a lake that is so large it has its own weather systems and sea states. These islands are often the remnants of ancient glacial activity. As the massive ice sheets retreated, they carved deep basins into the continent, leaving the hardest rock sticking up like a thumb. They are the high points of a drowned continental interior, offering a glimpse of what the land looked like before the ice melted. Just a quick one. Would love it if you hit subscribe. On to the next one. Level 5. The artificial island, built by human will. Some islands were never meant to exist, until humans decided they would. Dubai's Palm Jumeirah was constructed using roughly 94 million cubic meters of sand dredged from the Gulf. Engineers shaped it using GPS-guided rainbowing, spraying sand into precise arcs to form its iconic palm silhouette. Today it functions as a fully developed neighborhood, home to tens of thousands of residents. Its sister project, the World Islands, was designed to resemble a map of Earth. Large portions were sold, but development stalled after the 2008 financial crisis, leaving many islands only partially built. A reminder that engineering ambition doesn't always align with economic reality. In Japan, Kansai International Airport sits on an artificial island in Osaka Bay. Built on soft marine clay, the structure has experienced major subsidence, measured in dozens of feet since opening, requiring continuous engineering adjustments to keep it stable. And the Netherlands may be the masters of this level. Flevoland, created through the Zuiderzee Works, is an entire province reclaimed from former inland seas. Covering roughly 1,410 square kilometers and home to around 445,000 people, it exists because of an intricate system of dikes and pumps. Without them, the land would revert to water. Level 5 proves that with enough engineering and persistence, humans can redraw coastlines. China's artificial islands in the South China Sea represent the military application of island building. Between 2014 and 2016, China created over 3,200 acres of new land by dredging sand from the seabed and piling it onto coral reefs until islands formed above sea level. Fiery Cross Reef became a 677-acre island with a 10,000-foot runway capable of landing fighter jets. The construction destroyed coral reefs that took thousands of years to form, and international courts ruled the island building violated maritime law. China ignored the rulings and continues to occupy the islands, effectively creating unsinkable aircraft carriers in contested waters. These artificial islands aren't just engineering projects. They're territorial claims made from sand and concrete, proving that nations can literally manufacture geography to support political objectives. Artificial islands represent a shift from geography to geopolitical geometry. When a nation builds an island, they aren't just creating real estate. They are attempting to claim the 12 nautical mile territorial sea and the 200-mile exclusive economic zone that comes with it. However, under the UN law of the sea, an artificial island typically doesn't grant the same maritime rights as a natural one. This creates a bizarre legal gray area where a piece of land is physically real, but legally invisible for the purposes of international borders. We are increasingly living in an era where the map of the world is being painted by dredgers and concrete mixers, challenging our very definition of what constitutes natural land. Level 6. The tidal island. Islands that refuse to commit. Tidal islands live in two states. At high tide, they're surrounded by water. At low tide, they reconnect to the mainland. Mont Saint-Michel in France is the icon of this transformation. At high tide, it rises like a medieval fortress from the sea. At low tide, vast mudflats stretch around it. The tidal range can reach around 14 to 15 meters. Locals famously say the tide comes in like a galloping horse. Dramatic, but not entirely wrong. Water can advance quickly enough to trap the unprepared. To restore its natural rhythm, France replaced the old causeway with a raised bridge in a major restoration project, costing roughly 185 to 200 million euros. The bridge reopened tidal flow beneath the Mont, allowing it to reclaim its island identity. Further north, just outside Edinburgh, Craymond Island offers a quieter but more unforgiving version. At low tide, a narrow concrete causeway stretches across the Firth of Forth, marked by concrete pillars like stepping stones into the sea. Misjudge the tide, and the route disappears, cutting the island off entirely until the water recedes. Going much further east, South Korea's Jindo reveals a temporary sea path to Modo during exceptional tidal conditions. For a short window, people walk across the exposed seabed before the ocean returns and erases the route again. Level 6 islands don't change shape, they change identity. Lindisfarne in England, known as Holy Island, has been a tidal island for over 1,300 years. The island was a major center of Celtic Christianity, and monks created the Lindisfarne Gospels, illuminated manuscripts from 700 AD that are among Britain's greatest cultural treasures. Vikings raided Lindisfarne in 793 AD in one of the first Viking attacks on Britain, and the monks had to time their escapes around tides. Today, a causeway connects the island to mainland during the 5-hour window when tides are low enough. The causeway has refuge boxes on stilts where people who misjudge tides can climb to safety while their cars submerge. The Coast Guard rescues dozens of vehicles annually from people who ignored tide warnings and got trapped. Tidal islands create a unique relationship between humans and nature. You can't ignore the tides or you'll be stranded for 6 hours waiting for the ocean to retreat. Level 6 islands are the shapeshifters of geography. They remind us that the boundary between land and sea is a moving target. In places like St. Michael's Mount in Cornwall, the transition happens so precisely that you can watch a paved stone road slowly vanish beneath the waves until only the tops of the rocks remain. For the people who live on these islands, life is dictated by a celestial clock, the moon. You don't check your watch to see if you can go to the grocery store, you check the tide charts. It's a rhythmic binary existence that forces civilization to yield to the gravity of the solar system. Level 7. The recursive island. Islands within islands. Within islands. Now, we end with the "this shouldn't exist, but it does" category. For years, Taal volcano in the Philippines was geography's ultimate inception story. An island in a lake on an island in a lake on an island in the ocean. Volcano Island sits in Taal Lake, which sits on Luzon, which sits in the Pacific. In 2020, a major eruption altered conditions inside the crater. The main crater lake temporarily drained and changed shape, proving that in volcanic landscapes even the water isn't permanent. Recursive geography here isn't just complex, it's unstable. If you want a more permanent example, head north to Canada's Arctic. On Victoria Island, one of the largest islands on Earth, lies one of the most famous real-world examples of nested land and water. An island in a lake on an island in a lake on an island. It's clean, almost mathematical, like a fractal carved into permafrost. Then there's Manitoulin Island in Lake Huron, the largest lake island on Earth, covering about 1,068 square miles. It contains over 100 lakes of its own. In one of them sits Treasure Island, an island in a lake on an island in a lake. Around 13,000 people live there year-round, driving highways across what is technically layered recursion. Level 7 proves something unsettling. Island is a relative concept. With enough water and enough land, geography can stack almost indefinitely. Indonesia's Lake Toba offers another example of recursive geography. The lake fills a supervolcano caldera from an eruption 74,000 years ago, and in the middle sits Samosir Island, nearly the size of Singapore. Samosir contains Lake Siddahoni, and that lake contains a small unnamed island, creating an island in a lake on an island in a lake. But here's where it gets strange. Samosir Island is almost completely surrounded by water, but a narrow strip of land connects it to the shore, so technically it's a peninsula pretending to be an island in a lake. The local government built a canal to cut through the land connection, officially making Samosir a true island, which means humans can decide whether recursive geography exists by digging a channel. These recursive islands break your brain because they prove that island becomes a relative term depending on how many layers deep you're looking. Vulcan Point in Taal is tiny. You can walk across it in 2 minutes, but it's more geographically significant than islands 1,000 times larger because of its nested position within 5 alternating layers of land and water. Recursive islands are the ultimate challenge to our sense of scale. They suggest that geography is fractal, that the patterns we see at the level of a continent, land surrounded by water, can repeat at smaller and smaller scales until you're looking at a puddle in a rock on a hill. It forces us to realize that the ocean is just the largest bucket of water we have, and the mainland is just the largest piece of dirt. In a recursive world, every piece of land is just waiting for the right flood to turn it into an island, and every lake is just waiting for a volcano to rise out of it and start the cycle over again. Which level broke your brain the most? Drop it in the comments, and subscribe for more geography that feels fictional.